Hi, my name is Paul Abernathy, and welcome to another episode where we talk about calculations. And in this series, we go over all the most important calculations that you're going to have when thinking about exam preparation, preparing you apprentices for your journeyman license or your journeyman for a master's license. Now, in today's episode, we're going to talk range calculations, and we're going to move through these pretty quick. So we don't want to make them overly complicated. But what we're talking about is table 220.55, which is a complete table when you're dealing with household ranges, cooktops, things like that. And we're going to do these calculations, and there's a bunch of notes under it. Now, there's 5 notes. Most importantly, we're going to use note 1, 2, and 3 when dealing with feeder and service calculation applications. Note 4 deals with branch circuit calculations. And then we have a note 5, which is dealing with instructional programs where you might have something like home ec in school or what have you. And so that's when you might use this table for that application. And we're going to cover all of those things. Now, we're going to kind of keep this as simple as possible and cover the most important things that you need as an apprentice or a journeyman electrician in order to pass that test to move to the next level. And so there are basic calculations that you have to be able to understand. Now, we're not going to get into all the nuances in 210.19 for tap conductors, for branch circuit taps, for ranges and whatnot. We're not going to get into that. That's in a branch circuit series that we do. Here, we're really going to focus to the actual table 220.55. That's where we want to focus this episode on. We're all talking about some branch circuit applications under note 4, and those would be real specific. But for general purposes here, we're really going to talk about the table and all the things that are associated with that table. All right. So the first things first, though, we really have to understand the code. And so we need to look at this table we're going to talk about an awful lot during this series, and that is table 220.55. So let's go to that in the National Electrical Code. And again, we're doing the 2017 edition here for this series. And you see table 220.55. Now, this table has 3 columns to it, as well as the number of appliances, in our case, number of ranges, but yeah, it's number of appliances. And we have a column A, we have a column B. Now, A and B deal with the demand factor. Okay, and we'll use these terms interchangeably today, but that's the demand factor. Now, column C is dealing with the maximum demand, and this is your maximum demand down here. And you might see that these values get increased for certain types of ranges, let's say, that exceed 12 kW. But for purposes of our training class today, or this video, we need to understand that these values here in column C are a maximum demand, and that's shown in a kW value. These are shown in a percentage, okay? So you're going to have a multiplier here that's going to be based on whatever the rating is of the actual range or whatever the cooktop or whatever the appliance might be. You'll have a multiplier here, and it's a percentage. All right, so that's kind of gives us the overview. Now, if we go back to the main table, or the main heading here, it says demand factors and loads for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances over 1 3/4 kW rating. Okay, so that's what this table is dealing with. Now, it goes on to remind you that, okay, we're going to see a lot of things that take place in the notes today. But it reminds you that column C values are to be used in all cases except otherwise permitted in note 3. So you're permitted to use some allowances in note 3, but in all cases you can use column C. But you do have this permissive allowance in note 3, and we'll obviously talk about that when we get into note 3 a little more detail. All right, so we kind of got an understanding what the table looks like. Again, we're in the 2017 National Electrical Code. You need to go to that and get on this table. And once you have this table up, we're going to go into the presentation now. And I'm going to present to you a bunch of questions to kind of help establish how we use these different columns and how we move through this if we have an exam. So let's do that now. So let's go on and get into the presentation and we'll look at it. So here's it. We're dealing with table 220.55. We're dealing with range calculations at this time. Now, first things first, we're looking at individual ranges. Each one of these ranges we show here on the screen. If it's a 9 kW, 10 kW, 11 kW, 12 kW, all right, that is the actual rating on the appliance, or for the appliance, in this case, a range. But we want to know what is the actual maximum demand for each one of these. And so when we do that, we're going to look, because it's 9, 10, 11, and 12, we need to establish which column do we use on table 220.55. Because that's the most important part here, is we have to determine which column we're going to be working with. All right, so with that case, we're dealing with a 9, 10, and 11, or 12. Okay, and we're dealing with each one of these individually because we're trying to prove a point here. All right, so let's go back to the NEC and look at it. Now, under the NEC, each one of them was a single appliance. That's what we're dealing with. And we're just trying to find what the maximum demand is for each one of these single appliances. All right, so the maximum demand for the 9 kW would be 1 appliance. And it's not over 12 because it was 9. So the maximum demand is going to be 8 kW. So what about the 10 kW range? Only one of those. So if it was one range and it was a 10 kW, the maximum demand is going to be, again, 8 kW. Again, we're not in B and A because the values of these ranges are higher than 8 3/4. So that's going to be in column C. Now, what about that 10 kW? Well, again, no change here. If it was one 10 kW range, then it would be 1, and then you go over here and it would still be 8 kW, and that's what you use right here, 8 kW. And again, lastly, we had an 8, what do we have? A 9, 10, 11, and 12. So what would be the actual maximum demand for a 12 kW range? Well, you guessed it. It'd be 1 appliance, and it would be 8 kW. So let's go back to the presentation and see if that's what it turns out to be. So we've determined that for each of these individually, and we're not adding all these together. This is not an example. We just want to know what it is for each individual one. And so whether it was 9, 10, 11, or 12, the answer is going to be 8 kW for either one of these. Okay. Now we'll stay in column C and we're going to do another example. So what if I have 30 12 kW ranges and I want to know what the maximum demand is for 30 12 kW ranges. All right, so that's pretty simple. We're going to go back over to the actual code. And when we look at the code, we've got 30 of them. So we have 30 12 kWs. So we're going to go down here to 30. And we see that this goes from 26 to 30. And then over here, it says, well, you've got 15 kW. That's going to be your base value. And then it's going to apply 1 kW for each range. Well, we know we have 30 of them. All right. And they're all 12. So they're still in this column. They don't exceed 12. And so basically it's 1 kW times 30. So it's going to be 15 kW plus 30 kW. So let's go on back to the code and see if that's correct. Or the PowerPoint. So here we go. We're in column C because our ranges were 12 kW. And as it said, it was 15 kW plus 1 kW for each range. We established that there's 30 of them. And so 1 times 30 is 30. So 15 kW plus 30 kW equals 45 kW. So if you have a calculation question on your exam that has 30 12 kW ranges, you're simply going to use column C. You go down and find the number, which is 30. You come across and you follow what it says under column C. That's pretty simple. Now, what is the demand factor for an 8 kW range? Well, let's real quick go back to the code because we're looking for an 8 kW range. So we got to establish what column we're working in. All right, so let's go back to the code. And if we look at the code and we're dealing with an 8 kW, well, it could fall under column B because 8 falls between 3.5 kW through 8 3/4 kW. So I got B, but I also got C. And we remember the general rule here was that C applies to all cases except where permitted by note C. And if the permission results in a smaller value, then I want to be able to use that advantage, especially when I'm sizing for services or feeders in part 3 of Article 220. Now, that brings me to a key point here. Let me bring it back to me. If I'm doing a load calculation, or I'm doing these calculations for ranges, as I should say, then that means that I'm using the standard method of the code. So I'm in Article 220, but I'm in Part 3, which is standard. Now, there are optional methods, but the optional methods actually take the nameplate value and apply it there. So if you're getting examples like this on your exam, then you know that you're actually dealing with a standard calculation. Now, on an exam, if they're giving you range calculations, and there's usually 1 or 2 or 3 range calculations, then it really doesn't matter that it's really germane to the standard method. You're simply just solving these simple range calculation questions. So don't get overly dwelling on that. Just simply solve what you have presented to you in the exam. That's all you're trying to do here. If I was in a real world calculation, I can use the standard method or the optional method. And if I was using an optional method, which ultimately results in a smaller service most of the time, then if I was doing that, then I would actually take the nameplate rating of the appliances and work it that way, or the range, or whatever. But here we're using the standard method, and that's what pertains to these types of uses with table 220.55. So I just, kind of want to make that clear so you kind of know how things work. And now we will have some videos and training on commercial cooking equipment and things like that, or even optional calculations later. But really, we're just really focusing right now on household applications under the standard calculation method that uses table 220.55. That's what we're working on right now. All right, let's go back to the code, actually back to the presentation. All right, so now we've established that we have an 8 kW range, so it's going to be in column B, which is again 8 3/4 through 3.5 through 8 3/4, and we have got a not over 12 kW, which is column C. Now, this brings in the first note we're going to use, and that is note 3. Now, note 3, and I should show you where that is, so if you're not familiar with it and you're taking an exam, note 3 is down here. Now, these are notes. They are very much applicable to this table. If it had informational note, then it would be just good information, but these are to be used in your calculations. And so here's note 3 right here. I'll highlight that out. There you go. And let's read it so we kind of get an understanding of it. Now, if I have a value, and here our question was an 8 kW range, but if it's over 1 3/4 through 8 3/4 kW, in lieu of the method provided in column C, which I could just go to column C like the charging statement said for the table, but in lieu of that, I'm allowed to do this. It shall be permissible to add the nameplate ratings of the household cooking appliance, in this case was an 8 kW, rated more than 1 3/4 but not more than 8 3/4, and multiply the sum by the demand factor specified in column A or column B, okay, for the given number of appliances. So we would basically take the actual nameplate value and we would multiply it by the demand factor that's in column A or B, which one is being used for this case. In our case, it's 8 kW, so we're in actually column B. Now I'll go on to read the rest of it because we'll use it later. It says, where the rating of cooking appliances falls under both A and B, in other words, I might have 2 different columns in use here, it's the demand factor for each column shall be applied to the appliances for that specific column, and then the results will be added together. And of course, we'll see that in a minute when we go over that type of calculation later. All right, so in our case here, it's an 8 kW range. So we know it falls in B, but we're using column B in lieu of using C. But we want to compare the two because we want to take the lowest value, okay? The lowest value of the two. Well, common sense would probably tell you that since we're going to have a demand factor, which is a percentage, that we're probably, in this case, going to be better off with the column B choice. But we got to do the math to see that. Now, that might not be the same result if this range was actually larger than 8 kW. But then again, I wouldn't be able to use column B in that. So, all right, so in this case, we have let's do this. It says the 8 kW range would be 8 kW under column C. And we want to verify that. So we go here to the NEC. And we're using column C, be one range, and it was 8 kW. And the actual maximum demand would be 8 kW right here. Oops, not right there, right there. So that's what we would have. So it doesn't matter, even if it was rated 10, 11, or 12 in this case, it would still only be 8 kW. And we saw that earlier when we did that kind of that quick overview. All right, now, since we're using column B, we know that the one range takes the actual value of kW value, which was 8,000, and we're allowed to apply demand factor. In this case, it would be 80%. So we're going to do that. And we'll go back. And so then we would take the 8 kW and we would do that times 80%, which results in a 6.4 kW, or if we were trying to solve for pure watts, then it would be 6,400 watts. Okay. Now, why would I might do that? So, look, I could have, let's go and talk about that now. I could have a question on the exam that wants to know what the ampacity is. And it gives you all these values for the ranges, but ultimately, you're going to have to convert it to watts. And then you do Watt's law, and then you're going to take these in this case, it was the 6,400 watts divided by 240 volts. And that's going to give you what the amps are going to be. And that's what you're going to use to size the conductor and what have you. All right. So you might get that kind of question on the exam where it wants you to take it down even further in order to get you to the amps. But if the question is just asking you for what is the maximum demand or what is the demand factors and all those type of questions, then you very much want to stay into the table. Okay. So kind of be aware of that and really read the question. It's really key that you read the questions here. All right. So in this case here, we're going to have the choice of the two. Well, I'm going to go with column B because I like the 6.4 kW better than the 8 kW. All right. So it's a lesser value. And the code allows me to do it by note 3. Now, what is the demand factors for 6 8 kW ranges? Well, in this example, the demand factors can be in column B or column C. Again, we're still in that same scenario as we were just a second ago because it is simply 6 8 kW ranges. All right. Now, since they're 8 kW, they still firmly fit in column B, but we do want to compare it to C. Since we know we're going to have a demand factor percentage, then we know that it's probably going to result in less than C anyway, but we've got to do it. So what do? Well, here's the note down here in case you forget it. We'll keep it here. So we have 6 8 kW ranges. So what's the values in column C? Well, let's go to column C. And we have 6 8 kW. So we go down here to 6, and that's what we 6, and we come all the way over here for column C, and we're looking for the maximum demand. And at this case, it says 21 kW. So that's what the kW would be for 6 ranges, okay? And none of these ranges exceed 12 kW, so we're okay. Now, in this application, let's go back because we're going to compare it now. And when we look here, we now need to say, well, let's use column B. And we know that column B deals with 3.5 kW through 8 3/4 kW. And obviously, we fall in that range. So it's 6 8 kW ranges. So it's 6 times 8 kW times 43%. Well, where do we get this 43%? Well, that's under column B. And we're going to go to do that now. So let's go under column B and find out how we got that value. So here's the code. I'm going to go back. let's see, where am I? Okay, I'm back in the code. And we went down to 6 here. There's 6 ranges. And the column B, they're firmly, each range is obviously 8 kW, as we saw. So the value is going to be 43%. And that's going to be our demand factor. And that might be simply, be honest with you, that might be one of the questions on the exam. It simply wants to know what is the demand factor. And in that case, it would be 43%. It's not what our question is, but that's what you could get. All right, so let's go back to the question. So here it was 6 ranges times 8 kW times 43% results in 20.64 kW. All right, and obviously that is less than 21, but they are so close for all intensive purposes. The 20.6, you'd probably go up to 21 at that point. So really, it's not much difference in the two here. So that one kind of worked out that way. Now, let's look at this one. Now, what is the demand factors for one 3 kW range and one 6 kW range? Now, here's that example we were reading in note 3 here, where it says, wait a minute. My range falls under 2 columns in 220.55. How do I achieve this? All right, well, the code says right here in note 3, it says where the ratings of cooking appliances fall under both column A and column B, which is what we've got here, the demand factors for each column shall be applied to the appliance for that specific column, and then the results are added together. All right, so that's what we've got here. So we've got an A and we have a B. So column A is one range at 3 kW, and under that, we saw that for one range, it would be 80%. And under column B, the 6 kW range under column B would be 80% as well. Now let's double check these because we want to make sure we have that right. So when we go look at the code, we see that we have one appliance under the column A, and that was 3 kW. So the actual value here is 80%, so we got that right. And then the one appliance that uses column B, we fall under it, and that is also 80%. So we've got that right. So we chose the right demand factors for our equation. So let's go on back to it. So that's what we did here. 6 kW times 80% and 3 kW times 80%. That's 2.4 kW and 4.8 kW. You simply add them together, and that results in 7.2 kW. Now, comparing that, because we're doing this in lieu of using column C, but we do want to compare it to column C because we ultimately want to take the one with the lesser value. So we compare it, and we know pretty much it's going to be less, but we want to verify, always verify. So under column C, I've got 2 ranges, and so it would be as simple as going to the code and seeing here we have 2 appliances, follow all the way across, and results in 11 kW as the maximum demand. Well, in this case, this is another example where we're going to want to use the results of column A and column B because this is all part of note 3. Remember, note 3 allows me to use other than column C or in lieu of column C. So that's the benefit of that. All right. So in this case, we're going to use 7.2 kW for our values if we're calculating for service or feeder applications, for loading, to do load calculations. All right, so now let's look at another one here because we're kind of just going through all of these. Now, what is the demand factors for 4 5 kW ranges and 7 8.5 kW ranges and 9 3.5 kW ranges? Now, one thing you'll notice is that all of these are in column B, okay? Because all of these fall within the scope of column B. And we want to verify that. So we have a 5, an 8.5, and a 3.5. So we're going to go and just verify that. We're going to look at column B and say, okay, it's 3.5 through 8 3/4. That's going to put us in column B. That's where we want to be. All right. So now let's go back to the code or back to the presentation. And so in note 3, it's saying, look, you'd simply take the sum okay, of all of the ranges. And then once you have the sum, then you take the actual total number of all the ranges, and that's when you use column B, and that's where we're going to find our demand factor. So we're going to do all that right here. Okay, and we are going to compare it to column C again because we are in note 3 and we're doing this in lieu of using column C. Okay, so we want to make sure we compare the two. Common sense should tell us that it'll be less, but we want to do the math. So we have the 4 ranges at 5 kW, and that is 4 times 5 is 20 kW. Then we have 7 ranges at 8.5 kW, that's 59.5 kW. And then we have 9 ranges at 3.5 kW, and that equals 31.5 kW. Add all of these up, okay? And that's going to result in 111 kW. Now, you also want to add up the number of ranges we're dealing with, and it's 20. And that's what we do here. Now, let's do column B. So the total was 111 kW, all right? But we're dealing with 20 ranges. So that's where we're going to actually get our demand factor. So let's go over and look at the code in column B and do that. So we've got 20 ranges. That's why we needed to get the number of ranges. And we come over here. We're in column B because we said all of those ranges fall under column B. So that would be 28%. That is the demand factor that we use. Okay. So we're going to go back to the presentation and see if our math is working out. So 111 kW, which is what the sum was, which is talked about in note 3. And we do that times 28%, which is our demand factor that we found in column B. And that results in a 31.08 kW. Now, comparing that to the column C for 20 ranges, that resulted in 35 kW. And we can check that again by looking at the code and see that 20 ranges under column C would result in 35 kW. Well, again, in lieu of column C, I'm going to use the calculation that got me the lowest value. And that's what I'm going to use when we're dealing with column B in this example. Okay? Not too complicated at that point. Now, what is the demand factor for a 13 kW range? Okay, so you might get this question on your exam. Now, first thing we need to notice is, and let's go back and look at the code really quickly. So in the code, we notice these values up here. Now, 13 kW obviously is not going to use anything to do with column A or column B. And if you notice column C, it says not over 12. So that's automatically tells you we're going to have to do something, because the value that we have is 13 kW. Now remember, these are the maximum demands here, but when they exceed 12, we're going to have to do something else. And notice that it says see notes here. All right, so let's go and see something. We're going to have to do something a little different for this calculation. Now, note 1 is where we're going to introduce this note here. And note 1 says over 12 kW through 27 kW ranges, all of the same rating. So in this case, this is just one 13 kW range. But let's say I had 5 of them and they were all 13 kW. Okay, then you would still use this note for that. Okay, we just only happen to have one here. All right. So for ranges individually rated more than 12 kW, but not more than 27, that's the whole purpose behind note 1. The maximum demand in column C shall be increased 5% for each additional kilowatt or rating or major fraction thereof by which the rating of individual ranges exceeds 12 kW. Okay, so we've got 13 kW range, and we know that it exceeds 12 kW. The math would be pretty simple. We can take 13 minus 12, and that equals 1. 1 is a kW, 1 kW, and the code said in note 1 that I need to increase it by 5% for each additional kilowatt. So that is 1 kilowatt. Okay, so that's 5% we have to increase the value. Now, it's a 13 kW range, and as we said, the actual demand factor is 8 kW. That was what we found when we used one appliance and the demand factor being 8 kW. All right. Now, again, I want to reiterate that because I have people that'll say, I still don't get it. What are you talking about? Again, Just because the range was 13 kW has nothing to do with the maximum demand here in this calculation. It's still just one appliance, and the demand is 8. The maximum demand is 8 kW. Don't lose sight of that. All right, so since we did that, we're going to take 8 kW, that was our maximum demand, times 105%. Now that 5%, again, is for that fact that it was 13 is 1 kW larger than 12. Okay. Now I could do this a couple different ways. Now I like to do 8 kW times 105%. And I always add if it was a major fraction. For example, if it was 13.5, then it would be from 12 to 13 is 1 kilowatt. But the 0.5 is a major fraction, so that's another 5%. So it'd be 10%. So I could do this. It could have been 8 kilowatts times 110%. Okay, that's how you do the major fraction if it's 0.5 and larger. Okay, but in this case it wasn't. It was 13, which is 1 kilowatt larger than 12. So it's 8 kW times 105% equals 8.4 kilowatts. Now I could have also gone 8 kilowatts times 5%. So 8 kilowatts times 5% equals 0.4. And then I could have added that 0.4 to the 8 kilowatts and we would have got the same value. It just really depends on how you want to do your math. That's up to you how you want to do it. I like to do it this way. I like to add my percentages to the 100% value. All right. Again, this is all under Note 1 that gives you all these rules for sizing. Now, the one thing to remember, Note 1 applies, and if you're taking an exam, let's come back to me and make this clear. If you're taking an exam, remember, Note 1 is when all of the ratings are the same. I can have 5 13 kW ranges. I can have 10 13 kW ranges, but the key here is all of the ranges are the same. Okay. Now we're going to do a calculation when the ranges are different ratings, but when they're all the same, Note 1 is going to apply. Remember that. Okay, so let's move on to the next one. Now let's make it a little bit complicated here, not overly complicated, but we're going to introduce another note here, and we're going to introduce Note 2. Now this is the one when we're dealing with ranges that are not equal ratings. They're unequal ratings. So we've got 6 15 kW ranges, and this might really be on your exam, folks. So I have 6 15 kW. When would you run into this if you're doing the range load calculation for an apartment complex, for example? And that might be all they ask you in the question. Now, there's 4 10 kW ranges, and there's 10 9 kW ranges. All right. Now, we're introducing Note 2 here. Now, let's read Note 2 before we deal with all this. It says, now, Note 2, when they're over 8 3/4 kW through 27 kW ranges, and they're unequal ratings, and these are, it says for ranges individually rated more than 8 3/4 and of different ratings, and all of these are, but none exceed 27 kW, and none of them do, an average value of rating shall be calculated by adding together the ratings of all ranges to obtain the total connected load. Okay, and I'll show you that in a second, how we do that. It reminds you that you're going to use 12 kW for any range that is less than 12. Okay, that's something we're going to have to look at here in the next picture or the next slide, but remember that because this one's 10 and this is 9, so we're going to have to make a change here. Now, and you're dividing by the total number of ranges, so we have to know the total number as well. And then once you do all that, the maximum demand in column C shall be increased again like we did in Note 1, 5% for each kilowatt or major fraction thereof by which this average value exceeds 12 kW. All right. Now, the most important thing to take away from this, folks, if you're on an exam, is these are different ratings, is that if you can use Note 2, falls within these size values, then you're going to take any of them that are less than 12 kW and you're going to make them 12 kW. So that's what we're doing right here. So we had 6 15 kWs. We need to get the total sum. So we do 6 times 15 kW equals 90 kW. Now these 4 that were 10 kW are going to be made 12 kW for calculation purposes. So it would be 4 times 12 kW, which is 48 kW. And then we had 10 9 kW ranges, but again, as it says in note 2, we're going to strike through that and we're going to make it 12 kW ranges. So it would be 10 times 12 kW is 120 kW. Now, remember we need to have the total number of ranges. That's important. So the total number here is 20. 10 plus 4 plus 6 equals 20. So we've got the sum, which ultimately was 120 plus 48 plus 90, which is 258 kW. And we have the total number of ranges, which is 20. Okay, now, note 2 says we had to find the average kW load by dividing the total kW by the total number of ranges. So 258 divided by 20 equals 12.9 kW. All right. Well, 12.9, this is still a major fraction, so it's going to go up to 13 kW is what we're going to use. All right. Now, how many kilowatts does 13 exceed 12? Well, we kind of had this before. It exceeds 12 by 1 kW. Or if you had a value that's larger than this, or you're doing a total different calculation, it would be whatever that value is minus 12, and whatever it's left in kW values, you would increase it by 5% for each individual kW and for any major fraction. All right. So in our case here, we're going to use column C because we're not in note 3. And remember what it said at the beginning of the table, we're going to have to use column C for this. Now, the first thing I'm going to do is I'm going to find the column, I'm going to find the number for 20 ranges. And I need to get that demand value, that maximum demand value. Okay. And I need to do that. And then, since in our case, the difference between 12 and 13 is only 1 kW, then we only have to add an additional 5%. So we need to go to the code and get what that demand value is, or that maximum value. So here we are at the code, and we have that maximum demand value. We come down here to the 20, and we come over, and it would be 35 kW. That is what our maximum demand. Now, we have to increase that by 5% because we had the difference between 13 and 12 was 1 kW. And that's what the note 2 told us we had to do. All right. So let's go back to the presentation. All right. And that was 35 kW times 105%. Just like we did before, I like to put the 5% on top of the 100 as it makes it a little easier to do the calculations. So 35 kW times 105% equals 36.75 kW. And that's the basis of using note 2 here. All right. Not that complicated. Just remember the key to take away from this one, and I'll come back to me because I like to talk key things. If you're dealing with note 2, then we obviously have ranges that are unequal values. And we also have to make sure that these ranges are going to fall within the parameters to be able to even use note 2. Okay. And so if we've established that, this is how you do it. And it's not complicated at all. You just have to make sure you read the question slowly and answer basically what the question says. A lot of people read things into a question that are not really there. Keep it simple. Don't make it complicated. All right. So we can move on. All right, so now let's talk a little bit about branch circuit demand factors. So in this question here, it says, what is the branch circuit demand? And in this case, we probably should say, what is the demand factor for a 1/8 kW range? And under note 4, it says, it shall be permissible to calculate the branch circuit load for one range, that's what we've got, in accordance with table 220.55. Now we're going to stop right there. All right, so because this is an 8 kW range, we look back at the code, we have to establish which column we can be in. Well, obviously it falls between the ranges here, so we're going to be in column B. All right, so we're going to be here. Now it's only 1, so we can save some time, and we know 1 is going to have a demand factor of 80%. All right, so we're going back here and look at it. And we're taking the actual kW rating of the appliance here. And let me make sure I'm back at the presentation. Yes, sure am. All right, so it's 8 kW times that demand factor of 80% equals 6.4 kW. Now, you know, we could compare it to column C, which would require it to be it would be an 8 kW, but why would you want to do that? We're permitted to use all the values of 220.55, and in this case, it falls under column B. So I can actually use this. So it's 6.4 kW is the value that I'm going to use for this calculation. Okay. Now, couple things I want to add here. If you look right here, what if I get an application where I'm sizing for the branch circuit and it's simply one wall-mounted oven or it's one counter-mounted cooking unit, like a cooktop? Well, if that's the case, we're going to use the nameplate rating of that appliance. Now, let's come back to me and I'll explain something to you. In your exam, you might get a calculation where it actually asks you what the amps are for a simple cooktop. And if it's 6 kW, and you're going to take that 6 kW, and for all intents and purposes, if they asked you what the kW was, then it would be 6 kW. But if I need to work that down maybe to size for the conductors, if that's part of the question, then I need to take that 6 kW, I need to turn it into actual wattage so I can use Watt's law. All right, so I can either take that 6 kW times 1,000, or if I know that the K means kilo, which represents 1,000, then 6 kW results in 6,000 watts. And if it's 6,000 watts and I'm using basic Ohm's law, then I take 6,000 and divide it by 240 volts, and that's going to give me an ampacity value. And that's the ampacity value I'm going to use to size conductors for this branch circuit. Okay, so that might be on an exam. So just kind of keep that in mind. Read the question. If it's simply asking you what the demand factor is for that one appliance, there you go. All right. You can use the table, whatnot. All right. So keep that stuff in mind. Just remember, we're dealing with branch circuits when we're in note 4. Okay. We're not dealing with column A, column B. We're dealing with branch circuit applications. All right. In other words, we're not doing feeder and service calculations for load. We're sizing for the branch circuit. So kind of don't lose sight of what we're working with here. All right. Now, in that application, we got some other components here. And I'm going to cover these here in a second in the next couple slides. The rest of note 4 I'll cover. But I just wanted to give you that basic information first. Okay. Now, what if the branch circuit demand factor, or what is it for a single or one 15 kW range? All right, we're still in note 4. Note 4 says that we're going to use table 220.55. So that tells us that, okay, well, I can use all of 220.55 for all intents and purposes. So in this case, I'm going to be firmly in column C because, as we saw earlier, 15 kW is most certainly going to exceed 12 kW. So that should give you a hint. We're going to have to do something, okay, in this value. All right, we're going to have to deal with something. All right, now, and that most notably should be your awareness that note 1 reminded us about a 5%. So that's how we're still going to apply it here. All right, so 15 kW, remember, minus 12. That's what's going to tell us our kW value that exceeds 12. And in this case, it's 3. And since we saw that it's 5% values to be used, then we're going to take 3 times 5 equals 15%, which is the percentage that we have to add to the value in column C because we exceeded 12 kW. All right, and we exceeded it by 3 kW, which results in 15 total percent. Now, the one range in column C, the maximum demand is 8 kW. We've seen this many, many, many times. But we have to increase it by 15%. So I do 8 kW times 115% equals 9.2. Now, the branch circuit has to be sized to carry 9.2 kW of load. Again, on the exam, if you needed to break that down into amps, then it would be converted into watts. Again, you 9.2, that's the K for 1,000. So that's 9,200 watts. So 9,200 watts divided by 240 equals 38.8 amperes. Okay. So that's how you're going to do it for a single 15 kW range. Now, something I want to keep in mind, and let me bring it back to me real quick. You might get an exam where it asks you, hey, I've got a 9 kW range. What is the minimum size branch circuit rating? And it'll give you all these off-the-wall numbers. And when you're taking a test, you immediately want to mark off the ones you know that are just not right, okay, based on all the training you've done. There's some that'll be plausible, and there's going to be obviously the right one. And so you want to look at each one of them. It's not really a trick question. You just got to make sure you read the question. All right. So what if they said, what is the minimum? And all the question asked you was, what is the minimum size branch circuit for a 9 kW range? All right. And that's all the question they ask you. And that's all the values that they gave you. Okay, well, let's go back and look at it. So what I did was I pulled this out of 210.19A3 of the NEC, and for educational purposes only, of course. And you'll notice the last statement here. It says for ranges of 8 3/4 kW or more rating, and again, in our example was a 9 kW. It says the minimum branch circuit rating shall be 40 amperes. Now, it might be larger, but the minimum branch circuit rating shall be 40 amperes. That is a very good exam question, okay? It really throws people up a lot. So don't forget 210.19A3. Again, also, this goes on to remind you, again, just to let you know, and we're not talking about 210 today. We're not going to go over, let me bring it back to me. We're not going to go over the branch circuits and the branch circuit taps for where you might have a cooktop and a oven and it's being supplied by a branch circuit. We're not going to go into that because that's covered in my branch circuit calculations component dealing with 220 and all the aspects of branch circuits, which are going to kick us back into 210 for some of those tap applications. And so I really want to cover that here. And you're not going to see that pretty much on the exam when it's a pure range calculation. I'm not going to say it's not going to be there. Again, if you follow all of these exam prep series videos, then you're going to get that in a later video. But we really want to stick to the table. We don't want to overwhelm somebody getting them off the table and start bouncing around in the code. We want to stay here. All right, so let's get back. So just keep that in mind when you're dealing with it, all right? And one thing to always remember that all of these appliances shall have an ampacity not less than the rating of the branch circuit. That's a no-brainer. Got to be able to have a branch circuit that can handle it. And not less than the maximum load to be served. So all based on your calculations, you will actually end up with a maximum load, and you have to make sure that that branch circuit can handle that actual load. And again, this part down here, you might want to highlight in your code book because that is going to be on the exam somewhere in the country. I guarantee you. All right, now it says, what is the branch circuit demand factor in kW for one 6 kW cooktop? This is not a trick question, folks. All it wants to know is what the demand factor is, or basically what the demand is. And in this case, the way it talked about this in note 4 is we have one single appliance and you use the rating of that appliance. So in this case, the actual value for a 6 kW cooktop is simply that, 6 kW. That's all the question asked you for. Now, if it wants to know the actual ampacity, then you would take this 6 kW. Again, you would do it times 1,000. Or you just know that 6K means it's 6,000 watts, and you divide that by whatever the voltage is. In this case, let's say 240 volts. So then you would just take 6,000 divided by 240, and that's going to give your ampacity value. Okay, and that would be the answer to your question. All right, not a trick question. It's simply wanting you to remember that you want to simply answer the question as it's written. Don't overcomplicate it. Just simply take what you see on the question. Don't figure in things like when you're doing, if it has a conductor question, don't figure in Ampacity, adjustment, and corrections when it's not being asked, that kind of thing. And that's a good segue for me to tell you that if you want to learn everything you need to know about adjustment and correction for sizing conductors and overcurrent devices and what have you, then you need to watch our video on derating Demystified. And it's on our YouTube channel. And it's a cool video that walks you through every aspect of how to size conductors, overcurrent devices, and whatnot based on the loads, the actual loads, whether it's continuous or non-continuous and all those things. So that's a real good video for you to watch because you're going to need to know those too for exam. Okay, so that's a good one to watch. All right. Now, what is the branch circuit demand load? All right, we're going to use the rest of note 4 here. Okay, and it says, what if I have a 5 kW cooktop and I have two 3.5 kW ovens? Now, all of these are in the same room. Let's say it's in a kitchen, and they're being fed by a single branch circuit. Okay, so now we look at these other parts of note 4. Now, here's what it says. And now it says the branch circuit load for a counter-mounted cooking unit and not more than 2 wall-mounted ovens, and that's our example here, doesn't exceed that, all supplied from a single branch circuit located in the same room, which is obviously we're dealing with it all in the kitchen, shall be calculated by adding the nameplate rating of the individual appliance and treating this total as the equivalent of one range. Now, once you do that, let me give you a little thing here. Once you do that, or you apply this rule, it now becomes one range. You treat it like a range. Then you go up and you use all of the values that are available in 220.55. A lot of people think that you can't use that, and you can, okay? Once it becomes a single range, because of this rule, you now treat it as a single range, all right? So let's go back and look at it. So in this case, what we had was 5 kW cooktop, and we had two 3.5 kW ovens, and you add this all together, and this equals 12 kW. Well, we got 12 kW, and since the value is 12 kW, we're going to go to column C because, again, column A and column B aren't going to apply here, and we're treating it as one range. So in this case, we're going to go to column C, and we know by now, you should know by now, that the demand factor or the maximum demand for a single range that doesn't exceed 12 kW is 8 kW. So what is the kW for this application? 8 kW, and that's what's going to be used to deal with this calculation. All right. Now, what is the branch circuit load for a 5 kW cooktop and a 3 kW oven? Now, I don't have two of them here. I got one cooktop and I got one oven. Well, nothing really changes here, except for you need to remember that when you do this, it does translate into a single range. And that means I can use column A, B, or C, whichever it falls into. Many people lose sight of that. All right, so look, 5 kW cooktop plus a 3 kW oven equals 8 kW. Now, since they fall between column B here, because now it's being treated as one range, that's what note 4 said, well, we're going to use column B. And column B is, for one range, we know that that was going to be 80%. All right, well, let's go back and verify it because we want to make sure we always verify. Here, we have one appliance treating it as one range, and it falls under column B, and the actual demand factor is 80%. So that's where we're at there. All right, so we know we're good. So what we've got to do is 8 kW, which is the value that we achieved here, times 80% equals 6.4 kW. So the branch circuit would be sized to carry the 6.4 kW load. And again, if we wanted to break this down into finding the ampacity values, that we convert this to wattage. 6.4 kW translates into 6,400 watts. And at that point, you divide it by the actual voltage. In this case, let's say 240, and that's going to give you an ampacity value, and you size your conductors according to that. Okay? Again, this is dealing with note 4 and all of the rules that are found in note 4. Lastly, we're looking at note 5. Now, note 5 it will come back to me because this is a pretty simple one. Note 5 is saying, hey man, you can use all of these notes. You can use table 220.55. If I'm dealing with an instructional program like you might have in a high school, you have home ec, where they're actually using household ranges for their cooking and things like that. They're teaching home economics or some other type instructional program that's using household ranges. Well, we're not talking about cooking, commercial cooking equipment. That's in a different episode, right? We're talking about the use of this table. And this table means we're using the standard method. And that means we're using household type of cooking equipment. And so in here, it's saying, well, I'm using a household cooking equipment in this instructional program, and it might be like a home economics, and I want to be able to use this entire table for that, and yes, you can. You don't have to turn it into a commercial cooking equipment calculation, because most of those home ecs that in school, like house school that I was in, they're just simply normal ranges, and they're teaching them how to do cooking and baking and whatnot like that. It's not the commercial calculation, all right? So don't lose sight of that. And that's all Note 5 is really dealing with. It's just giving you the permission to use all of the values and all of the benefits of table 220.55. That's all that it's telling you there. And again, who didn't enjoy home economics in high school? Now, I wasn't in home economics, but I was more than willing to sample the food that came from home economics. And I can tell you what, the kids and the guys and girls that I went to school with, man, they could cook. And I had no problem eating. So that wasn't an issue. All right. So that looks like that's it. But let's come back to me. So hopefully you've learned something here. Excuse me. That you've learned how to, excuse me, I get choked up there. So excited about all these calculations, I get choked up and gonna choke to death during the video. I know there's some people out there like that. There's haters everywhere. But what we've learned is how to deal with Note 1, how to deal with Note 2, how to deal with Note 3, the little secrets and tactics of Note 4 when you're dealing with branch circuits. Note 5, which is saying, hey man, if it's an instructional program and you're using household cooking appliances, you can use all of the notes. You can use everything in table 220.55 to the best of your ability. That's all that's saying. So you've really learned. Now, you've also learned that when I'm using Note 1, that all of the ranges are equal value. When I'm using Note 2, it's all the ranges are unequal values. And so Note 3, I'm able to use column A or B in lieu of column C if it's applicable. Again, Note 4 is telling me that I do branch circuits based on the values that are given to us in Note 4. If I have one cooktop and two ovens or one oven, then I can do the conversion, and now I treat it as a single range, and then I apply all the benefits of table 220.55, depending on which column that it falls in, treating it like it's a single range at that point. So I think we covered everything. At this point, I will remind you to visit our website. It's masterthenec.com or electricalcodeacademy.com. And we have a bunch of URLs, but those are the main ones. If you want to follow us on Twitter, then it's simply at masterthenec. You can get all that from the website. I encourage you, if you're trying to really study for exams, that you go to our Facebook page. Now, you go to Facebook, like it says here in the ticker below, you go to our Facebook page and just search for Master the NEC, or you can click the link on our website. And when you go there, you'll also notice that we have what's called a closed forum as well. So the open forum is just for anybody to post and can contribute. But the closed forum, you have to be a member. And if you're an apprentice, you're a journeyman, you're an electrical engineer, you're an electrical inspector, or any of that, then I'll let you in. All you got to do is request that you want to join, and I'll let you in. And in there, we have a bunch of people, I think well over 300 now, that allows you to ask questions and you get good responses, and there's no dumb questions. You ask whatever you need to ask. And if somebody comes back real snarky or somebody gets really mean, then I'm going to clean it up. Again, this is not a democracy. It's a closed forum. Okay, it's a monarchy. It's my monarchy. I'm going to make sure that everything in there is not hazardous. I'm going to make sure that it's good sound code information. I'm going to make sure that everybody's treating everybody with respect, and you're actually getting your questions answered. And that's what we're all about here in the Master of the NEC. So hopefully you get something out of this. God bless until next time. You need to stay safe out there. And I'm really trying to help you pass your exam. I don't know it all. Never claim to know it all. But I'm really trying to help you understand how to apply all the calculations that you need to be able to pass an exam. Now, a lot of our exam prep videos will talk about how to read a question on an exam and how to dissect the area in the code that you need to go to. And that's simply called code lookup training. And we just kind of go through the code and answer questions, and I tell you where to go. But calculations are something different. You really need to learn the basic calculations. Now, if you're doing motors, we have a video on motor calculations. If you need to know how to do adjustment and corrections, we have a video on adjustment and corrections. If you need to know how to do welder calculations, we have podcasts on our website as well as videos that teach you how to do those calculations. So they're all out there for you to learn. Okay, so there is no excuse for you not to excel in this industry and become the best electrician in your company, to someday own your own company and lead the next generation of electricians. That's what I'm after, because I'm not going to be around long, okay? You need to carry this on. So I want to thank you for coming. God bless. Until next time, again, stay safe out there.